Hola, soy Jeff Crider, soy de IMAHelps, somos de una fundación de California y estoy aquí en Rehabilitación en Santo Domingo y estamos trabajando con un equipo de estudiantes de robótica del Centro de las Ciencias de los Lagos Grandes de Cleveland, Ohio, y estamos aquí para cambiar las vidas a los niños y jóvenes con amputaciones. Ven conmigo. Y vamos a entrar a la sala en donde están trabajando los estudiantes del Centro de las Ciencias de los Lagos Grandes. Utilizan la última tecnología robótica para diseñar y fabricar manos y brazos mecánicos. Y estamos aquí en donde se crean estos milagros. Vamos a conocer al director del programa de robótica del Centro de las Ciencias de los Lagos Grandes. Se llama John Bradshaw y está aquí guiando a sus estudiantes en el diseño y la producción de estos dispositivos.
Hello, my friends. Thank you for joining us. My name is Jean Dar, as you've already learned, and I'm with the Great Lakes Science Center's Robotics Initiative. We've brought together high school students from 19 different high schools in Cleveland, Ohio, in the United States. Kids that are part of robotics teams. In fact, they're rival teams, but on this project, they've come together. They're hoping to make a difference by changing the lives of young people all around the world, including right here in Santo Domingo. Behind me is one of our students. This is Gabriel. Gabriel's doing some design work for us right now. He's using a computer-aided design program that will allow him to modify a limbs that we're to create. Gabriel learned these skills while building robots for competition, but now he's found a better use for using them. Now, in this area over here, we have 3D printers. The work that Gabriel is doing, the design work that he's doing, we'll take that and we'll take those modified designs and we'll transfer that information to these 3D printers. Stephen is busy at work making sure that the printers are working properly, but these are part of the design that Gabriel just came up with. We can actually manufacture all the parts that we need to make those hands. Leading that effort is one of the best mentors that I know. He's actually a teacher at one of these schools. His name is Tim Hatfield.
So what we're doing over here is 3D printing some of the palms, the elbow cuffs, and I believe we have some fingers and hands going over on that printer. We're actually setting up a 3D scanner to see if we can get this thing going up and going, and we're gonna probably 3D scan some of the arms that come in and see if we can translate those to the Anchor Make 3D printers and possibly 3D print some hands.
So the idea of creating a 3D printed prosthetic hand is a multi-stage approach. It starts with the initial assessment, where we meet the patient, we take some measurements, counsel with them to let them know what to expect, and then if everything works out well, we'll design a solution based on the needs for that patient. And once it's designed, we can begin fabricating parts. Now, some of the parts have to be molded specifically to fit that patient, and that's what Lewis is doing with the help of Aria. Aria actually leads our assembly team, but at the moment, she is working to form some of the parts that have just come out. Now, we use a combination of things, from using a heat gun to actually placing the material inside hot water. One of the unique properties of this type of filament, the type of plastic that we use, is that it can be thermal molded. Just by placing it in some boiling water for about 15 seconds, we can remove it from the water, and now we can mold it to the shape that we need. For harder items, we'll use a heat gun, and sometimes we have to do that to further modify the opening to make it big enough for the patient. Let's take a look at the assembly process. So here's students from the robotics teams, and this is the location here in this facility where they're actually assembling the parts. The team is really hard at work, and you can see all the parts that were 3D printed, and now they're here being cleaned, sanded down, and then assembled. We use dental elasties, the same rubber bands that you would use for braces. We use those as the ligaments in between the fingers. Down here, the team is beginning to assemble some of those now. Once that's complete, then our team begins to put the rest of it together. Just extraordinary. I want you to know that this is a student-led initiative. The students came up with this idea themselves, and the brainchild behind this is this lovely young lady right here. This is Yadizet.
I originally came up with the idea to start Hands Across Borders, and we all pitch in from different FIRST robotics teams to come together and make 3D printed prosthetics, and they're all built by the students.
So as you can see, it's a really big job, and each one of the students has a critical role to play. Just like building a robot to compete in competition, to do this life-changing work, everybody has a part. From designing, to fabricating, to cleaning and assembling, right down to training the recipient how to use that new device when they receive it. There is no role that's more important than any others, and all are required to make a product that will change a life.